I want to make a truth table about a special kind of statement, and we won't see what kind of statement it is until we're done. So let's just start making the truth table for, how about if P then Q, and not Q, then not P. So if P then Q, and not Q, then not P. Remember I told you truth tables could be difficult in one of two ways. They could be tall, they could be wide. This one's going to be kind of wide, right? Because I've got a bunch of little steps I need to do before I can get to the end. So, again, I start with, what are my letters? The only two letters here are P and Q. Even though they both appear a couple of times, P and Q are the only letters. Putting them alphabetically at the beginning, I have P first, Q second. Two choices for P times two choices for Q gives me 4 rows that I'll need. Then filling in my values under my truth simple statements, starting on the right, true, false, true, false. Take a step to the left and double up for true, true, false, false. There's a lot to unpack here, but I think I can almost do it in order, right? Looking inside of here, I'm looking inside of here. This first column should be if P then Q. Then I want to AND that with not Q, so I'm going to have not Q. That'll let me do if P, then Q, and not Q. Then I want that whole thing, the conditional error, to not P, so I need not P, and then I can do the entire statement. Now if you're feeling overwhelmed, any one of these columns shouldn't be too hard, because we're only ever looking at most 2 inputs and then 1 truth table. Our first column here, in fact, is exactly the conditional table in order. Hold on, I think I ran out of conditional tables. Right, so if we look at the conditional table compared to what we have, we're doing the same exact thing. We have true, 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 false, false, true, false, false. That's going to give me, if true then true is true, if true then false is false, broken promise, if false then true is true, if false then false is true. Great. Next up, not Q. So all I need to do is ignore those things that aren't Q and then switch it to the negation of it. So Q is true, false, true, false. Not Q should be false, true, false, true. Looking at this column, I have if P then Q. I have the negation of Q. This is what I don't have, so I need a conditional or a conjunction table. And I need to look at these last 2 columns. So doing so, I see true and false. True and false is false. I see false and true is false. I see true and false is false. And I see true and true is true. Okay, now I need the negation of P, so I need to look at everything, or just look at P. I need to cover up everything except P. P was true, true, false, false, so the negation of P should be false, false, true, true. And now I'm to the end, I'm to the last spot. I need this first, this second, and the conditional table. Put the conditional table where we can see it. So let's move all this stuff this way. Okay, it's a dangerous small prop sometimes. So looking at these last 2 columns, in order, first I have if false, then false. False, false gives me a true. If false, then false. Okay, false, false gives me a true. If false, then true. So false first, true second gives me a true. And then if true, then true. True, true gives me a true from the top row. Okay, here is our full truth table for this statement. Notice that it's always true. This statement is always true. That means it has a special name. Sorry, it doesn't mean it has a special name. It has a special name because it's always true. A statement that is always true is called a tautology. Okay, There are much simpler tautologies. In fact, P or not P is a tautology. But this is also a tautology. Anytime you do the big truth table, you get all trues, that thing's a tautology. We have a special name for a conditional statement that's a tautology, like this one was. So a conditional statement that is a tautology is called an implication. Kind of because the first thing actually implies the second thing. And then one more quick piece of terminology for you. A statement that is always false is called a contradiction or self-contradiction. Okay, I'm being a little loose with the terminology here because in fact, a tautology isn't just a statement that's true like in the world that we live in. For example, the sky is blue. You can say, well, the sky is blue is always true. That's not what we mean by tautology. We don't just mean something that is true. By tautology, we mean something that has the shape of something that could only ever be true. Okay, so it has to be a compound statement. It has to be so that whenever you do the truth table, you get all trues. Doesn't matter what P and Q are. That's a tautology. In the same way, a contradiction is a statement that is always false because of its shape. It has to be a compound statement, and it has to be false because of the truth table, not because of what you're talking about. A really simple contradiction would be P and not P. Right? P and not P will always have the truth table false, false, so that would be a contradiction.